So guys, this is the Polyglot programmer. I haven't made any videos in like a week. I've been really studying a lot. But I'm still doing exercises though. I'm just not doing so many videos. To be honest, I make these videos because one, I want to try to help people that are struggling with this exercise just like I am. And another reason is because when I try to explain it to you guys, it helps me also to understand. So I think that's a very good way to learn. And if you don't like making YouTube videos, maybe you can just try to explain the solution to a friend, and that also works. And another reason is because if you want to try doing some coding interviews, on those interviews, what they say, one of the biggest tips that they give you is that they want you to think out loud, right? So they want you to be able to explain the solution. So you kind of need to practice that, because when we're actually coding by yourselves, we don't usually talk out loud, right? So it's good to get some practice with that. So yeah. So today I'm gonna go about this problem. So the problem is validate stack sequences. It's not a very complicated problem, but you do have to think a little bit, and you kind of, and for this one, I used a greedy approach, which is you basically uh, uh, you basically keep trying different solutions until you find the optimal one. A rough way to explain it. That's one I kind of have a hard time to explain it also. But this problem is, it goes like this. So you basically are given two sequences. One is supposed to be pushed, and the other one's supposed to be popped with distinct values in from a stack. So a stack, when you push stuff, the last one stays on top, right? And when you pop, you're gonna pop the last one, and then the second to last, and then the third to last, and so on and so forth. So in return true if they could be, if the popped could be a result of the push and pop, they could be a result of each other, right? So in this example here, for example, you have 1 2 3 4 5 and 4 5 3 2 1. Oh, the first thing that came to my mind when I read this was like, oh, okay, so I just compare the first to last, second to last, and I do that with 2 pointers, and then it's easy. But that would only work if they were all pushed and then they were all popped. Then that would make sense. But that's not what the case here. You actually don't know the order. So in this case, for example, he pushed 1, pushed 2, pushed 3, pushed 4, and then he popped 4. So that's why pop came first. And then he pushed 5, and then he popped 5, and then he popped 3, pop 2, pop 1. So that's why you kind of have this order. So he push 1 2 3 4, popped 4, push 5, popped 5, then pop 3 2 and 1. So this is the problem. So the way I go about solving this problem is I keep a count. I mean, first of all, I have an extra data structure, which I have another stack, which and I keep a counter. So every time that I pop something from this extra stack that I create, I increase the counter, and my result at the end will be return counter if counter equals my lane of popped. So if I popped just as many items as I had here, then I'm good. Then I have a good solution, right? So let me declare this guy counter equals 0 and stack equals nothing. So, and what I do here is that I'm not gonna, is that I'm gonna have a for loop on my pushed. So I'm gonna basically push all the items. I'm gonna append all the items from my pushed to my stack, and I'm gonna compare that every time that my last item on my stack is equals my counter, meaning that it's at that point on my popped, then I'll pop from my stack, my temporary stack, and I increase my counter. So then I'm for num in pushed stack append num. So I'm appending all of them, right? And then while then I do a couple of checks here. So while I do have items on my stack, because I don't want to get an error here, and j is less than my lane popped, right? Because I don't only want to pop as many items as I have on my popped list, right? And this is the important one. My last item in my stack is equals the number of the index that it's on the number of items that I have already popped. So I haven't popped anyone, so I'm gonna compare first my last item in my stack with the item 0, and then if this is true, then I'll just stack pop that item and counter +1, and this will work. So I just want to show you guys, like here. So I'm gonna get these guys just use it as an example before I have to. So I have my counter equals 0, and I have my stack with nothing, right? So here, and then I'm gonna start iterating over my push numbers. So I add 1. Okay, I do have items in my stack. Is j less than length of popped? It is. Is my last number in my stack equals item 0? Oh, item counter. Not. I was explaining item counter, which is 0. Item 0 in my popped 4. No, it's not. And then I add 2. Same thing. Is 2 equals 0 in my popped? No, it's not. 3. Is 3 equals 0 in my popped? No, it's not. And then I add 4. Is my last item in my stack 4 equals item 0 in my popped? It is. Then I pop this guy and I increase this by 1. And then I go and I append the 5. Wait. Anyway, sorry. And then I go and append the 5. And now I'm here, right? My counter is here. So is my last item in my stack equals number 1 in the counter? Yes, it is. And then I pop this guy and I increase this. Okay. Is 2 equals my last? Yes, it is. And then I pop this guy equals 3. Is 3 equals my last? And I pop this guy equals 4. And it's 4 equals my last. Then I pop this guy equals 5. And then there's length is 0. And then I return if my counter is equal my length of popped. And if I haven't made any mistakes, I have forgot this. J. Oh, counter. And there you go. Accepted quite fast. I did use some extra memory, but yeah, still the time complexity here is it's all of n, because I mean I had to iterate over all the number of items, and then all of these are cheap operation, they're constant. And space complexity is always also of n, because I may have to create a guy this size that is the same size as this one. That's it. See you next time. Hit the subscribe button. Cheers.